Get ready to blow your mind. Black holes aren't monsters devouring everything in sight. That's just a cosmic myth. In reality, a black hole is an incredibly dense region in space where gravity is so intense that nothing, including light, can escape once it gets too close. But here's the kicker: black holes don't actually explode. They evaporate over time through a process called Hawking radiation. That's right, even the universe's most powerful force has an expiration date. Buckle up. Let's debunk some myths and dive into the amazing world of black holes. Think you know what a black hole is? Well, it's not a cosmic vacuum. It's actually the universe's ultimate packing feat, crammed with more matter than anywhere else, squished into an incredibly tiny space. This supercompacted density creates gravity so strong that light can't escape, making it seem empty, but trust us, it's the opposite. Now, let's talk formation. The most common black hole birthplace is a supernova explosion. Yes, you read that right, a star blowing up in a massive display of celestial fireworks. Alright, so let's go back to that massive star we talked about, 25 times the mass of our sun. When it reaches its final act, it explodes in an incredible supernova display. Think of a cosmic fireworks show. However, beneath this explosive spectacle, the core of the star is on a mission of extreme compression due to gravity. If enough mass is packed into this collapsing core, it can reach a point where it forms a black hole. And when we say a few times the mass of the sun, we're talking about what many astronomers consider a regular or stellar mass black hole. But hold on tight, because there's another beast lurking in space: the supermassive black holes. These cosmic giants can have masses millions, even billions, of times greater than our star, making them truly the universe's most fearsome and fascinating objects. So, let's talk about the epicenter of galaxies, where supermassive black holes reside. These cosmic monsters can weigh millions to billions times more than our sun. While we don't know for sure how they formed alongside their parent galaxies, one thing is certain: a black hole encounter spells disaster. You see, if you were unfortunate enough to fall into a black hole, it's game over. But here's the catch: even before reaching the black hole's point of no return, its intense gravitational pull would have torn you apart at the molecular level and vaporized you due to friction with space debris. So, in reality, death would likely occur long before your journey into the black hole's abyss. As you inch closer to that stellar mass black hole head first, gravity starts going crazy. The force on your feet becomes thousands of times stronger than the pull on your cranium. It's like being stretched out like taffy, a phenomenon so bizarre, scientists playfully call it spaghettification. By the time you reach the event horizon and enter the black hole's clutches, you'd be more or less a long, thin stream of matter, maybe even several miles in length. And guess what? This cosmic stretching might not exactly hurt. But don't worry, you won't be around to feel it anyway. Zooming towards a black hole from thousands of kilometers away, well, that's not going to be a long ride, all over in just milliseconds. But before you even reach the halfway mark, some voracious black holes might snatch you up like a cosmic vacuum cleaner, stealing matter from nearby stars or gas clouds. As material gets pulled into its orbit around the black hole, it forms an accretion disk, a massive whirlpool of matter. It's here that things start to get scorching hot. We're talking millions of degrees. This intense heat triggers a spectacular release of X-rays, blasting out in all directions like cosmic fireworks. Buckle up, because we're about to dive into the mind-blowing world of black holes. But first, let's talk about how they come in different sizes. Think of them as cosmic cousins. You've got your intermediate mass black holes, which weigh around 100,000 to 1,000,000 times more than our sun, your supermassive black hole heavyweights, tipping the scales at billions of solar masses. And then there are the teeny tiny microscopic black holes, barely larger than a speck of dust, about 22 micrograms. Now, can these cosmic behemoths go boom? The short answer is no, they're incapable of exploding by their very definition. But here's the thing: we still don't fully understand what goes on inside a black hole, so our knowledge is more like a rough outline, and scientists are still trying to fill in the blanks. Let's talk about these cosmic powerhouses in a way that's easy to grasp. Picture black holes as the universe's ultimate hoarders. The larger and greedier they get, the tighter their hold on everything surrounding them, including light, which can't escape their gravitational pull. But here's what's mind-boggling. No matter how much stuff you throw at a black hole or what happens to it, it just keeps getting bigger. Now, some super smart guy named Stephen Hawking had an idea that challenges this notion. He proposed the existence of something called Hawking radiation. This theory suggests that even though nothing leaves a black hole's vicinity, there's a tiny bit of energy that leaks out due to quantum effects near its event horizon. It's like if you left your house with a slow leak in the window. Over time, air would escape and eventually it'd be gone. Similarly, Hawking radiation could potentially drain away a black hole's mass. So here's the deal. Tiny black holes have an ultimate fate of disappearing over extremely long periods, billions of years, without consuming anything else. They literally evaporate due to this mind-bending concept called Hawking radiation. But when it comes to the Big Bang, we're still left with so many unanswered questions about what exactly made up that initial cosmic spark. Scientists are like detectives trying to solve a puzzle and have thrown around numerous theories, string theory being one of them, which proposes tiny strings as the fundamental building blocks of our universe. However, these ideas remain hypotheses until proven otherwise, serving as educated guesses in the absence of concrete evidence. To describe this mysterious starting point, scientists use the term singularity, referring to a single point with no dimensions at all, and interestingly, also apply it to black holes, but bear in mind that there's no deeper connection between these two uses of the word singularity. Now let's dive into some mind-blowing physics. We can actually use complex math to describe what happened in the universe just fractions of seconds after this initial Big Bang singularity started expanding. But sadly, our current understanding stops there. It doesn't reach back far enough to paint a clear picture of what that cosmic spark truly was. Contrary to popular belief, black holes cannot explode. Instead, they gradually evaporate over time through the phenomenon known as Hawking radiation, leaving behind nothing but a faint memory of their once great mass. It's almost impossible for a black hole to suddenly explode and push things away from it. Its incredible pull would suck everything towards it, including our Earth, if one were to ever come too close, leading to an inevitable cosmic catastrophe. But there is another theoretical possibility. Could a black hole transform into what's called a white hole? Unlike a black hole that sucks matter in with its powerful gravitational pull, a white hole would push all the surrounding matter and energy away from it, essentially acting as its polar opposite. That's all for today, folks. We've explored some truly awe-inspiring concepts. From the Big Bang singularity that kickstarted our universe to mind-bending black holes and their mysterious evaporation through Hawking radiation. And we even touched upon the fascinating idea of a white hole, essentially a cosmic pusher rather than a sucker. If you found this video as captivating as I did, hit that subscribe button for more edutainment adventures and don't forget to give it a like. And remember, if you're looking for more videos on mind-blowing science topics, check out the link displayed below. Until next time, stay curious and keep exploring.